Hi, hello guys, this is Vijay, chemistry lecturer from Ailabad Junior College. As you know that we have started our NEET series and we are discussing about each and every chapter in detail, chemistry as well as in biology. Okay, so today we are going to start our unit 2 atomic structure, okay, on the basis of NEET series. So in this chapter today first let us discuss in detail about the theory part, then followed by numericals we will practice based on this particular chapter, then followed by we will discuss with the NC. Okay, now how could we confirm that these rays are said to be cathode rays? These rays are said to be cathode rays. How could we confirm? It is very simple. Yes, the rays which are arising from the cathode and which are attracted towards to the anode. So here just one thing, CRT based questions. Then finally we will discuss the previous year practice question papers. Okay, we should observe clearly that the cathode rays are there which are negatively charged electrodes. Yes, negatively charged electrodes are present here. And the straight opposite, what is there? Positively charged electrode is there. That is anode. So there are rays which are emerging from the negatively charged electrodes to the positively charged electrodes. So it is said to be what? The rays are cathode rays or negative rays. Yes. Now are said to be cathode rays. And these cathode rays, how could we confirm? Only in this experiment, only cathode rays are produced. How could we confirm? Yes, it is very simple. They made a small hole. And this result, what actually the rays are moving towards to the anode in a straight path, straight line. At the same time, when they made the hole, what happened? The rays even penetrated. Penetrated meaning is going towards in the hole present in the anode. And they made a hole in the anode as well as behind the screen. I mean behind the electrode. They kept a substance on the screen. They kept a substance on the screen here. So that substance is nothing but zinc sulfide. Okay, they kept a substance that is zinc sulfide. Set in yes. Actually, the zinc sulfide is what? It is a coating on the behind screen of this anode electrode. Now you see the rays which are emerging from this cathode and passing towards to the anode, where the anode made a hole and these are again going towards to the penetrating to the hole, and finally what happened? It produced what actually the experiment, I mean J.J. Thomson and team, what they did actually, they made a hole in the anode. They made a hole in the anode. Yes, they made a hole in the anode. Finally what happened? It is striking on the screen of the zinc sulfide, okay, and it produced a bright spot which is produced on the screen, that made the confirmation of cathode rays. Okay, so from this experiment we should remember that there are two things. One is what actually, why particularly we are using the gases under low pressure. Yes, that is one reason. The second reason is why we made holes on the anode electrodes. So we made holes on the anode electrodes that would help for this cathode rays which is penetrating through it and falling on the zinc sulfide screen and started to striking and produced a bright spot. Okay, so this confirmed the particular ray which is said to be cathode rays. Okay, yes. So this is about the discovery of cathode rays. Next question is, actually we discussed about the discovery of cathode rays now. Then what do you mean by electron? What is the relation between this electron and cathode rays? We should know. Yes, that means the characteristic features of the cathode rays which are emerging from the cathode electrode to the anode electrode. Yes, so it has some characteristic features, and these characteristic features are used or helped us to know about the subatomic particle electron. Okay, now let us see what are the characteristic features of these cathode rays. First we know about the characteristic features of cathode rays, and that could help us to know what is electron, a subatomic particle present in the atom. Yes. So let us see one by one what are the characteristic features of the cathode rays. Okay. So the first characteristic feature, which is the cathode rays which are moving from the cathode to the anode. These rays are moving from the cathode to anode. Cathode is nothing but what? Negatively charged electrode. So the rays are passing from negatively charged electrode to positively charged electrode, anode. Okay. So that is the first characteristic features of the cathode rays. Next, these rays are observed with the help of a particular fluorescent substance, fluorescent material. Fluorescent meaning is colorful material. Okay. So this fluorescent material we used in this experiment as zinc sulfide. Yes. So zinc sulfide helped us to know the particular cathode rays visibly because these rays are passing from this negatively charged particle, negatively charged electrode to the positively charged electrode, and we made a hole here. That would help us for what? The penetrating of the rays towards this anode rays, and finally hitting or striking on the zinc sulfide. So that made a bright spot. So we come to know that these rays are passed through. Yes, that is what the second characteristic features of the cathode rays. Next, what is the third characteristic features? The third characteristic features of these rays are, these rays are traveling in a straight path. The rays are traveling in a straight line until unless when we are disturbing these rays with a high power electric or magnetic field. When we are applying a magnetic field or when we are applying an electric field, what happened? These rays started to deviate. Which are not going in under their straight path. Okay. Yes. This is also confirmed. It is also confirmed. How it is confirmed? It is confirmed by the formation of a shadow on the opposite side of the cathode rays. Okay. So when a small object which is placed between this cathode and anode rays, so the shadow which is falling on the opposite direction. Okay. So a small object which is placed between this cathode and anode, what happened? Its shadow will be formed on the opposite direction. Okay. So that is what the third characteristic features of cathode rays. Now let us see the next characteristic feature. So the next characteristic feature, that is, when these rays are executed from the cathode to anode, in between, if we keep a little pedal wheel in their particular path, what happened? The wheel started to rotate. So we are placing a small wheel here. So what happened? The wheel started to rotate. When the high electricity passed, the rays are emerged from the cathode to anode. It started to disturb this pedal, a lightweight pedal. No, a metallic object or a small lightweight pedal that started to rotating. It shows that what? These particles has kinetic energy. Yes. The particles which has both mass as well as velocity. Though the particles have some mass, and also it has a velocity, a particular speed. So due to that mass and velocity, when it is hitting this pedal, it started to rotating. So it shows that this particular race which has kinetic energy. Okay. Now next characteristic feature, let us see. These rays which are consist of electrons which are produced by the ionization of gases. We know that already, because these rays are produced because of the low pressure gas present in the glass tube. Low pressure gas present in the glass tube. So when the ray is activated, it is falling on the, the electricity is falling on the, when the electricity is passed, high voltage electricity, the electricity is falling on the gaseous particles and making it as ionization, gaseous particles into ionization. Okay. So that could help us for the movement of this particular ray, particles movement. Okay. Next characteristic feature, that is when we are applying a electric field or magnetic field, as I said already. So when we are applying a electric field or magnetic field, beside the cathode rays, what happened? It started to deflected. And the rays expected from negatively charged particles. So that we could consider this as a negatively charged particle. See, we are placing a magnet beside this or here. What happened? These rays started to deflected from its normal path. So it shows that it has negatively charged particles. Okay. Finally, these rays could be able to produce X-ray when they strike against the surface of the hard metals. So when these rays are falling on a hard metals, say for example like tungsten, molybdenum, these are the few examples. Okay. So when it is falling on the tungsten or the molybdenum, which started to emitting X-rays. So this is also one of the characteristic features of these cathode rays. So these all characteristic features helped us to know these rays, the discovery of the electron. Actually the fact is what? All these characteristic features of this cathode rays, this concluded that the particular cathode rays which consist of negatively charged particles, these rays are made up of negatively charged particles, and these negatively charged particles are called as electrons. Okay. Now these electrons are said to be the basic and fundamental constituents of the all atoms. So this discovery credit goes to J.J. Thomson and his team. So Crookes and J.J. Thomson team, this entire team, they did, but actually the credit goes for J.J. Thomson. Okay. So this is about the discovery of cathode rays and the properties of cathode rays. So the discovery of cathode rays finally concluded that the rays which contain the fundamental negatively charged particles which are said to be electron. So the electron discovery happened first in the beginning. Now let us discuss the charge to mass ratio of electron. What is the meaning of this charge to mass ratio of electron? Yes. So how he concluded, I mean the J.J. Thomson in the year 1897, how he concluded the charge to mass ratio of electron? Yes, same experiment. Yes, the discovery of cathode rays. Here only one change we did. We placed a magnet. We placed a magnet beside the cathode rays when it is traveling. Okay, the setup is same as usual. Yes, cathode electrode, anode electrode, which are connected to the high voltage current is passing through. So the gas which is present inside, which has low pressure, so started to emit the rays, and the rays passing through a straight path. So when we are keeping the magnet, okay, in between, actually it started to what? Started to deflect. But whereas we placed two more electrodes here, positive and negative, so that it could not able to deflect up and down, so it started to moving and finally dispersed on the fluorescent screen. Okay, this is said to be fluorescent screen. So now this is the experimental setup. How J.J. Thomson he could able to find the mass ratio of electron, let us see. Okay, so he made the setup of cathode ray tube and applied electric and magnetic field which are perpendicular to each other. Say for example, see here we have electric field as well as magnetic field. It is said to be electric field, and it is said to be magnetic field. So both are there in a perpendicular to each other. Yes. So the cathode rays which are started to moving in a straight path in the cathode ray tube. So Thomson suggested that when the electric or magnetic field which is applied, then these rays are deviated from its path. So this experiment is based on the principle that the extent of deflection of the electrons which is depending on the charge on electrons. Okay, mass of the electron and strength of the electric and magnetic field which are applied. See, charge and mass of the electron is what? So based on this electric field, here electric field is applied and here magnetic field is applied. Okay, so it made that particle to move in a straight path and started to deviating. Okay, based on that he concluded the mass and charge ratio of the electrons. Okay, suppose you see, when the electric field which is applied, the electrons started to deviate from their path and hit the cathode ray tube at the point A. Say for example, here 3 points are there. So when the electric field is applied, what happened? It started to go and deviated towards electric field, that is what? Spot A. In the absence of both types of field, what happened? The electrons as usual it go in a straight path, that is what the spot B. Yes. So when only the electric field is applied, magnetic field is not applied. When only the electric field is applied, what happened? The rays which are traveling straight line, it started to deviate towards the electric field. Deviate towards the electric field. This chapter we will continue with one more video with further more topic. Until then, thank you guys.